British writer and poet Eden Phillpotts once wrote, "The universe is full of magical things, waiting patiently for our wits to grow sharper." Scientists have understood this for centuries and have been in constant search of ways to see things in the universe that we cannot see with our human eyes. The quest to see the unseeable began in the late 1500s. Many scientists credit Galileo with the first microscope, as he invented the telescope, and the crude technology is roughly the same: two lenses at opposite ends of a tube. Many microbiologists credit Hans and Zacharias Janssen. This father-son team were not scientists. They were opticians who made eyeglasses. They experimented with layering lenses and placing them in a sliding draw tube that could push the lenses closer together or pull them farther apart. This first microscope, made in 1595, could magnify objects 3 to 10 times their normal size, which was great for reading. The trail of making microscopes goes cold in Holland, and the next attempt at seeing the microscopic world isn't until the mid-1600s, when English scientist Robert Hooke improved upon the microscope design and employed instrument maker Christopher Koch to make the device. The lens combinations that Hooke used were significantly more powerful, increasing the magnification of objects up to 50 to 150 times, which allowed him to delve into the unseeable world. Hooke used his new microscope to examine cross-sections of cork, describing what he saw as cells, named after the small rooms that the monks lived in. He also examined snowflakes, fleas, lice, and plants. He ultimately published his discoveries in 1665 in a book called Micrographia, detailing the structure of the compound microscope and the discoveries of the cells. This microscope was not handheld, but had a base for the specimen and a place for the light to illuminate the sample. Even with these modifications, the samples were still viewed in dark conditions, and there were significant aberrations due to light diffraction. In 1668, Anton van Leeuwenhoek, a Dutch textile merchant, visited England and is rumored to have seen a copy of Micrographia, as it had become a scientific bestseller. It contained Hooke's drawings of his microscopic examinations of cloth. Van Leeuwenhoek saw the drawings of the microscope and the lens arrangement. Hooke stated in Micrographia, "If you take a very clear piece of a broken Venice glass, and in a lamp draw it out into very small hairs or threads, then, holding the ends of these threads in the flame, till they melt and run into a small round globule or drop, which will hang at the end of the thread. And if further, you stick several of these upon the end of a stick with a little sealing wax, so as that the threads stand upwards, and then grind off a good part of them, and afterward on a smooth metal plate with a little Tripoli rub them until they become very smooth. If one of these be fixed with a little soft wax against a small needle hole, pricked through a thin plate of brass, lead, pewter, or any other metal, and an object placed very near, be looked at it through it, it will both magnify and make some objects more distinct than any of the great microscopes." Leeuwenhoek was already a professional at grinding lenses because of his work in the textile business. You see, at the time, textile merchants used small lenses to look for imperfections in loose thread and fabric. He took notes of Hooke's methods, and upon his return to Amsterdam, he began to improve upon Hooke's design. The smaller the sphere, the greater the magnification. Leeuwenhoek had made tiny lenses that allowed objects to be viewed with a magnification of 300 times their normal size, much more powerful than Hooke's microscopes. By 1674, he had detailed animalcules, which he had named because they appeared to be tiny animals. We now know these as some of the most simple life forms, including protists, red blood cells, bacteria, spermatozoa, and diatoms. In essence, because of his discoveries, Leeuwenhoek is the father of microbiology. Since Leeuwenhoek's work, the scientific community has made great strides in developing more advanced microscopes. The most prolific type used throughout scientific research is called the compound light microscope. It has 3 lenses: the objective lens, field lens, and ocular lens, making it similar in concept to Hooke's microscope, but it uses tiny glass pearls as the basis for the lenses, making it similar in structure to Leeuwenhoek's microscope. With the combination of lenses, it can produce varying magnifications of 40, 100, and 400x. If mineral oil is used to counteract the diffraction index between the glass and air, you can use a 1000x objective lens. While the compound light microscopes and its predecessors all use visible light to view their specimens, science has advanced beyond using photons, as visible light microscopes have reached their limit. It wasn't until 1931 that the next major microscopic discovery was made. German scientists Ernst Ruska and Max Knoll stopped using light when they realized they could transmit electrons through a specimen to form a 2D image. This discovery led to the first transmission electron microscope, or TEM. 10 years later, in 1941, Ruska created a similar machine called the scanning electron microscope, in which he coated the specimen in gold and electrons bounced off to produce a topographical 3D view of the specimen. For years, these microscopes reigned supreme, and the SEM and TEM are still found in research labs around the world. However, the most recent development has taken electron microscopy to another level. In the past 20 years, Jacques Dubochet, Joachim Frank, and Richard Henderson created a technique for creating a 3D structure of a protein at an atomic level by cooling the sample to cryogenic temperatures. This new approach, called cryo-electron microscopy, or cryo-EM for short, was awarded the Nobel Prize in Chemistry in 2017. These new electron microscopes have come a long way from the days of Janssen Hook and van Leeuwenhoek, as they are now allowing scientists to see samples at the atomic level, magnifying specimens up to 10 million times more than the human eye can see. There is no doubt that with the passage of another 300 years of technological development, scientists anticipate that we will soon be seeing deep into the subatomic particles and quarks of atoms. So while Edom Philpott said that the universe is full of magical things patiently waiting for our wits to grow sharper, one could argue that the universe is full of magical things waiting for our microscopes to grow sharper.